Welcome again to my channel. Today again I'm back with another question. Today we are going to solve question number 91 of Leetcode decode ways, and it is marked medium. So let's first understand what the question wants us to do and what's given in the description. So the question basically says that we have intercepted the secret encoding of string of numbers, right? So the input will be of type numbers like this one, right? It will be the string, it will be a string, but it will consist of numbers only, right? Now what these numbers represent, each number maps to a particular alphabet, right? Like number 1 maps to A, that means number 1 means A, number 2 means B, 26 means Z, and these are all the mappings available. We don't have lowercase letters, we don't have special characters, nothing else, just from 1 to 26, A to Z, right? What we want to do is, if you see clearly, let's say this is the input, right? So each individual character can mean each individual number can represent the character, right? But they can also form a group to represent the character, right? For example, let's say I break here, right? So that means I get 1 here, I get 1 here, and let's say I break here again, break here. So the characters I'll get would be 1, then 1 again, then 10, and lastly 6, right? So 1 would mean A, 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 10 would mean whatever, and 6 would mean whatever, right? So this is the mapping, this is the code that we have decoded from this string, right? Now as you can see, I could have done this also, 1 1 1 and 0 and 6, right? But there is no 0 in our mapping, and there is neither 0 6, so 0 6 is also invalid. It can only be 6 or 0, right? It cannot be 0 6. So that's why we had to break at 10 to make it 10, right? Because the otherwise the decoding would have become invalid. So we have to check for that. So the question wants us to return the number of valid decodings that we can find, like this one, right? If it's invalid, we cannot count it in our answer. So that is the question, right? Now how are we going to solve it, right? So what we'll do is, we'll call a recursion call, we'll take an I, and the I will start from the first index, right? Now what this I will do is, it will break the string backwards. I mean, like a character, previous character, if you will, right? Like if I is here, we are saying that we are breaking it here, not here, right? Otherwise we would have started I from here. So what we are saying is, we'll take I from 1, we'll start it from 1, we'll keep on breaking the previously, right? Now if I moves on here, next index, we are saying that we can break like this. If I moves on here, we can say we are breaking like this, okay? So that's what I index will do. Next thing is, I'll just show you, we'll take a mappings like this, which will say that these are the only available values that can be accepted. Other values are invalid. Like if you see, 0 is missing here because 0 is not valid. Similarly, anything larger than 26 is also missing because in alphabet we only have 26 characters, A to Z, right? So other larger than 26 and less than 1 are all invalid. So we have taken a mappings map here, right, which we can use to check if what we have broken down is a valid um, code or not, right? So what we are going to do, as I said, we'll start from we'll start I from first index. Then we have two options. We have two options. Let's remove these. Either we will break, either we will break and it will be 1 comma 1106 and I will become 2 because initially I was 1, right? Here the I is 1, right? So I will move on in this index. Okay, that means we have broken the string, right? The second option is we did not break the string at that particular index. That means it's still intact and I has moved on to become 2, right? Now in this particular index we have the option of breaking here, which will give us 11 and 106 and so on, right? Again in this index we have the option of breaking here. Now whether we choose to break or not, that those are the options, right? If we choose to break it, we'll get 1 comma 1 comma 106 and I being 3, right? Or if we don't choose to break it, then it will become what? It will become, will be this, right? And I will become 3 and so on. Will keep on breaking until I goes out of bound, right? Now if I goes out of bound, we'll check if the what we have broken is valid or not, because we have to check validity. Because let's say we keep on skipping here, let's say from this index onwards we are not breaking anywhere, that means eventually we'll reach a state which would be like this: 1 1 106 and I will be out of bound, which means I will become 5, right? Because 1 2 3 4 5, right? Now when this happens, we are saying that we have decoded the message and the parts of it are 1 1 and 106. Now 1 means A, 1 again means A, but 106, does that mean anything? No. As I said, anything above 26 is not accepted. That means this code that we have decoded is not valid, which means from here we will return 0. Why? Because we did not encounter a valid uh, decoding, right? And similarly, if we, let's say, arrive at a correct decoding, which will look something like 1 comma 1 comma 10 comma 6 and index is out of bound, right? From here we'll return 1, saying that yes, this is one of the valid decodings that we have, right? So that's why we return 1 here. Now at this state from which we are getting this and this, we will say that just add up these two, right? Since we are sending 0 for invalid, it will not be counted anyway, so just add up 1 and 0, and we'll finally send from here. We'll finally send 1 plus 0, right? We can send that. So that will be our code, right? And one more thing, it's not like we are going to reach the end like index out of bound for everything. There will be another base case being, let's say here the index is, okay, let's say index is 3, that means it is here, right? Because 0 1 2 3, right? That means does not matter what we do here, right? If we skip or if we break, right? Let's say we break it. After we break, we'll get 1 comma 110 comma 6, right? An index out of bound, whatever, let's say 5 or whatever, right? In this particular case, even though the last part is correct, 6 is valid, but the middle which we just broke is not valid. So for such kind of cases, we'll not call this only. We will not call this. That means this is a wrong function call, right? We'll skip this call. Why? Because we have reached a invalid decoding midway, which we can prevent by checking directly here, right? So that also will do. So now let's implement this in the code, and it will be much clearer. So let's write the recursion function solve, which will take the string and the current index that we are on, right? As I have showed earlier, I've already copy pasted this mappings. Now the base case, which was if idx is out of bound of s, right? If idx is out of bound of s, what we need to check is only the last part, as I mentioned, right? Because if you are out of bound, we have ensured that previous codes or previous values are valid, right? Here also we are just checking the last value because the previous ones are valid. So that means we are checking if that value exists in the mappings or not. We are just checking for the last value, which is the full string, because we have already broken it into these parts. These parts don't exist in the string anymore, only this does, right? So how we can check? We can check if underscore comma okay mappings of s, right? And if it is okay, that means the last part also exists in the mappings. Then we return 1, as I mentioned, saying that this is a valid decoding way, right? Otherwise we return 0 because the last part was not present in the mappings. It is not valid, right? So that is the base case, if idx goes out of bound. Now for calling the recursion, we have again two options. Either we can break or we can skip, right? So two options, take or skip, right? But for taking, as I mentioned, we have to check validity. Before taking, let's say before breaking, we have to check validity of the previous part, right? Because future part will be checked later. right? Say I'm breaking here, that means I just need to check whether this one is a valid encoding or not, valid decoding or not, right? Because this will be checked eventually in the future calls, right? So I just need to check whether this part is correct or not, right? So that means that would mean um, first part would be string till idx, right? As I've said, the I, whatever I we are taking, it will mean that we are breaking here. So the first part that we are breaking off will be till idx. And in Golang, if you write like this, indexing like this, that means take everything from the start, because we have not mentioned any index here, from the start till the index, and not including the index. The index is exclusive, not inclusive, right? So the first, and initially take will be 0. Now we have to check the validity of the first part, that if the first part that we have currently taken is correct or not, right? So if underscore same logic, okay, mappings of first, if the mapping exists, then we can take it, right? Take will be solve of what will be the new string, right? We have broken off the first part, so we do not want the first part. We have already, like if you see here, we are breaking it here, right? We are breaking it here. That means we are saying we do not want this part, and this will be our new string. So that means s will be from idx till the rest. Now as I mentioned earlier, this first index is inclusive. That means since we are in this index, we are saying take this and the rest, because we are not mentioning anything in the second part, right? So we are saying take this I along with others, skip this. We do not want this, right? Because we have not included it. And now just think carefully what the index will be. We have broken this part, right? And I want the I to be here. I want the I to be in this part, because the next part that we can break is here, right? If you see below, the next thing we are breaking off is here, so the I is there. That means for in regard to this string, this is the 0th index and this is the first index. So whenever we are breaking, we are always landing on the first index. If you notice, even even if we, let's say, break here, or let's say we are breaking here, we are landing in this index or maybe this index, right? So that means whenever we are breaking, we are taking, idx will always restart from 1. Just like in this call, like we'll start this call by saying idx equal to 1, right? Not idx equal to 0. Oh sorry, idx equal to 1, not 0. So that's why every time we break, we are offering a new string, and so will the idx will be 1, right? And the other option is skip, which will be pretty simple. We'll just send the string as it is, since we are not breaking anything apart, and the idx will be increased by 1, right? Because we are skipping. As you can see here, either we can break off this part saying we don't need it, and the new string will emerge, or the string will remain same and the I will just be increased by 1, right? And as I said earlier, what do we need to return? We need to return the sum of these two. Now we'll call this return solve with s, and idx will initially be 1. Now if you run this, it should work, but let's see. And it is working. Now the next step will be memoization. If you see in the recursion call, the two things that are changing is the string and the idx itself, right? The string is also changing and the idx is also changing. So we'll memoize these using 2D array, right? So memo and the maximum values it can have is the length of the string only, right? Let's say we are breaking every particular index, so we want however many characters are there to be in the array, right? Because idx will also move from here to here, right? Yeah, excluding 0 because we're starting from 1, but we can like it does not matter, we can just ignore that. So idx will range from here to here, and the string, because since string is also changing, will also range from here to here, right? So it will be length of s. We can take length of s, but just for being extra careful, I'll just add 1. Then for I, range of memo of I equal to make again array of int, and the same thing, length of s plus 1. For j, range memo of I, every particular value will be initially minus 1. We'll pass this along, and it will be then we can check if the answer already exists. If memo of length of s and idx is not equal to 1, sorry, not equal to minus 1, then we can return memo of length of s and idx. Otherwise, we can just store the answer, memo of length of s idx equal to take plus skip. We need to pass it here also. Let's see if this works. Let's submit, and it is accepted. So that is all. This is the whole code. Thank you for watching, and subscribe if you learned something, if I could explain something to you. So see you in the next one.